Root mean square value or roughness is the key parameter to describe atomic force microscopy images, while grain size is the key parameter to describe scanning electron microscopy. Both techniques are fundamentally used for surface analysis. Here we have two samples. This is basically the pristine perovskite film here without this material, while this is a perovskite film but we modified with this material. So here we can see that both images are taken at the same magnification. This is very good approach, because I told many times that if you take with different magnifications, it will be quite difficult to compare, because the examiner and the reviewer will raise question that how you compare two images with different magnification. For example, if this is 1 micron and this is 500 nanometer, so it will be very difficult to compare both surfaces. So here we can see that in this pristine or pure film, we have grains but very small in size here. We can see that it's very small in size here, and because of that smaller grains we have larger root mean square value here. This is around 25 nanometer. This RMS value basically means the variation in height here. For example, we know that for example this at nanoscale the surface look like a mountains. The mountains means, so mountains have some valley and it has some the top level. So this is basically showing the variation in this roughness. Sometimes the mountain tall and sometimes the mountain low in height. So this basically shows the variation. So this is kind of roughness basically, right? So if we have a very large variation, so this means the surface is rough. If we have less variation, so the surface is smooth here. So we can see here the RMS value is 25 nanometer, but this value decreased to half value when we modified the surface with this material here. And we can also clearly see that here that the grain also increases in size here. But we are not talking about the grain, but we can compare with SEM analysis. But here this value give us the information that now this surface is more smoother than this one here. Why? Because of RMS value here. So when you want to write about this discussion, so we have to use this figure XAB present or shows or exhibits. We are not going to use the past tense because we have to write results in discussion, and in that section we have to write the word present here, right? And this is how I explain here. Now come to the SEM images. So we can see here that the pristine film. Here again, they took the images at the same magnification. Quite good gesture here. Yes. And from this magnification bar, we can also measure the grain size. How? For example, I will draw this dia here in this grain here. And yeah, this is somehow. And if I guess here, so these two are same. So this means this grain size is basically 500 nanometer. Yes, quite good approach here. And we can see that there are small grain here, but if we look into the modified film here, so we can see that all grain are large in size here. So there is a significant increase in grain size here. So this means that these two results basically reflect each other. This means they validate each other. Here we mentioned that if we increase the grain size, so we decrease the grain boundaries, and the grain boundaries are very detrimental. So the roughness basically comes from these grain boundaries as well. So when we increase the size of the grain boundaries decreases, and thereby we get more smooth surface here. Yes, the images I took from this important paper is the images I took from, and this paper is published in Micro Letters. This is the title of the paper, published by Wan et al. In 2025. And this paper is basically published under a common license 4.0. This is the link to the license.